Welcome back. We're writing Little Man Computer in C++, and we've got to the point now where we can actually run through a program and evaluate it, but there are still a few little missing bits and pieces. One thing I noticed is that we've failed to cover the case where the program counter goes beyond 99. That should be relatively straightforward to sort out. We don't yet have a very nice way of getting the program into the computer. At the moment we're just seeding memory manually, and we don't have a very nice way of dealing with I/O. If we were to be actually running this as a program, for example, we can't very easily put more than one inbox value in. So if we wanted to add two numbers that came from the inbox, somehow we would need to get that second value into the inbox before it was required, but after the first value had been taken. And that's a bit awkward at the moment. So there's still a few bits and pieces that need addressing. I think the first thing we should do is rectify that problem with the program counter. Now, the question is, does it say anything about what we should do if the program counter goes beyond 99? It doesn't appear to actually mention that in here. Yeah, so I suspect the best option. Well, there were two alternatives we could do. We could either just have halt the program if the program counter gets to 100, or alternatively, and I guess this seems a little bit more logical in the way that computers would work in real life, is we wrap round from 99 back to 0. So I think that's probably a slightly better way to go. We can write a test relatively straightforwardly for that, I think. So that would look something like program counter wraps when it goes beyond 99. So we can kind of seed that a little bit. So let's assert some value on the program counter that is perhaps 1. So if we put the halt, oh no, we can't do that, can we? We could. Okay, we can do that. Slightly dubious program here that probably wouldn't occur in real life, but that's fine for the purposes of exercising this, I think. Let's have a little man running things and a little man like so. And then if we start our program counter explicitly at 99, like so, and then we can say that memory 0 is our halt instruction, and memory 99 does some instruction that it doesn't really matter. We'll just grab the contents of the inbox and store it in the accumulator. So that should then leave the program counter in the correct place. So it'll start at 99, it'll find the input instruction, it'll run that, it'll increment the program counter to 100 at the moment and fail horribly. And when we correct, it'll increment it to 0. find the halt instruction and increment it to 1 and terminate. So that should be fine. I have no idea what this is actually going to do going off the end of the array. We'll see how that gets handled. That's just failed. It's run off into memory, as one does. So we can rectify that relatively straightforwardly by just making sure that this increment here is modulo 100 equals computer.program counter plus 1 modulo 100. And that should hopefully be sufficient to make our test pass, and indeed it does. That's fine. Let us commit that change, and that's all fine, isn't it? Git commit handle wrapping of program counter when it exceeds 99. That's fine. Good. So that's sorted that problem, and then we want to, I think, next make it a little bit easier to get a program into memory. And so perhaps we want to write something along the lines of how to do this in a sensible manner. So let's start by creating a little vector called program. Is that safe name? Yes, I think so. That has a program in it, and let's. It doesn't need to be anything particularly complicated. So we will have our load something from the inbox, put it straight out into the outbox, and terminate. That's fine. So then we need to assert equal. I have to have a couple of asserts here, which is going to be a little bit awkward. Unless there's a nice way of comparing two things, two arrays. I do not know. Compare two arrays in C++. What does this say? That's not quite what we want to do, is it? Because we want to compare the first n elements. So first n elements of a standard array in C++. It's not quite what we're after, is it? Let's for now just do it the easy way, and then we can tidy things up a little later. So we want a computer, and we want to say memory 0, all the way around, like so. So that's our assertion that we've loaded the program into memory. So we'll need a computer to allow that. And then what we want to say is something along the lines of man load program. And so we'll need a little man. And that should fail the test. And we've not quite written that correctly. Is that not how you initialize a vector? Do I have to say this? No, I've clearly errored somewhere. What is the correct? Yeah, five different ways of initializing a vector. Oh, we haven't typed it. Yes, not far away. So that should be this. No, that's not quite right either. Expected. This. Oh, yeah, miles away. We haven't done any of the relevant structural items here, which is a little careless. So, load program populates computer memory. So let's see what that does. We do not have a load program. That is indeed correct. So now we need a load program method on the little man, for which we first go here, load program. We're not changing this, so const vector. That's probably not the right type for this, but we will leave it at this for now. And we'll need to include a vector as well. And then we'll need to implement, at least superficially, that method. So void load program, no, little man load program with a vector of ints called program. There was a mechanism I saw for dealing with this slightly better. I think it's this. Unknown attribute unused. Let's see what that was. The question is this GCC specific? G and U unused. That looks like it. Yeah, maybe unused. Excellent. That's slightly nicer than our dubious hack before. Good. And we have 3 failures here. That's correct, isn't it? Because we are checking 3 values. This is not nice in terms of the API for testing, is it? So let's see if we can make it a little bit nicer by writing another assertion. So where are our assertions hiding? Okay, assert r equal. So what we kind of want to do is to say void assert r equal is there some sort of array vector base class thing, standard collection of things? Maybe it's just easier to look at standard array directly and see in the reference. Maybe we just iterate iterate over 2 standard arrays at the same time. Yeah. Well, you can, yeah, of course, that would be considerably more sensible, wouldn't it? You can just use the indices. So const. Oh, but what do you pass? Pass either standard array or vector to function in C++. That's not helpful, is it? Ah. So we could do that, could we? Take a pair of iterators. What does that do? Has anybody got a better suggestion? Can I just do that? Let's just take a punt here, shall we? And make something up and see if it works. So what was the template syntax type name? Okay, so template type name t, and then we want to say expected actual, and then say a count, and then we could say for auto I equals 0, I is less than count plus plus I, if expected I is not equal to actual I, then let's just do something temporary here to see if this is even worth pursuing. Then fail and break. Can do that and say failed equals true. Clean the dog's water bowl, very useful. We shall do that a little bit. That's broken my train of thought quite badly. Failed equals true. Okay, so and then if not failed, it's the wrong way around really, but that's fine for now. Cout pass. And then we could say in our program here, we can get rid of that, and then we can say assert equal. I wonder if it's going to get confused on the types. No, because it's got an extra parameter. Program computer.memory 3. That's unlikely that's going to work as the conflicting types for the templates. That's a shame, isn't it? In which case, let's come back to that and refactor it later. Rather than spending too much time trying to do something clever. So this should get us back to our failing test. Yep, and fails okay, at least for now. And then we should be able to make that pass by saying is that standard copy in, I think, for the that value, and then program.begin program dot, what's the, is it size, and computer.memory.begin. I think it's something like that. I believe we're going to have to include something like algorithm, is it? We will find out in a moment. Let's see if that's correct. Yep. Missing a bracket. Well, let's just see if it even builds in the first place. That looks promising, doesn't it? And it passes. Excellent. So that's good. The test is still a bit horrible in terms of the pass or fail state, because we've got 3 assertions in the same test. What I think I might do, is temporarily just write something custom in here. If and my 2 equals computer memory 1 and 0 equals computer memory 2, then we can't do that, can we? Because then we don't call. No, that's fine. So what do we need to call in our test? We just say add pass or add failure, don't we? So that's fine. So we can just say pass and then test result add pass, else we print fail, like so, and test result add failure. Does that work for us? Looks good to me. Excellent. Let us commit our work. And that's going to be add function to load program into memory. And we shall improve on that hopefully next time.